Hi, everyone, and welcome to Online Lecture 14, Reliability and Validity, Day 2. So we pretty much talked about reliability and validity of measures last time. And I think the only other thing I want to say about that is I want you to be sure as you're choosing your measure for your own study or measures, as the case may be sure to choose one or ones that have good reliability and validity. Let's try to not recreate the wheel by creating your own brand new measure. Let's try and find one out there that you can actually use, okay? And if you need help with that, as always, please feel free to contact me, okay? So now for today, for the second day of this, we're actually going to focus all our attention on research validity. So a little bit of a change of pace. Research validity has to do with the truthfulness of inferences or conclusions that you make from a research study. Okay, so you are always running a study to try to show whether you can reject or not reject a null hypothesis. You're trying to reach a conclusion. And how much can we rely on our conclusions? Well, it has a lot to do with research validity. Okay. And there are four major types that we'll talk about today. The first type, we'll probably talk about not for a long time, just for a little bit, because it's statistical conclusion validity. And it's pretty much what you studied in your statistics class, right? It's the validity with which we can infer that the independent and dependent variables covary. And it's inferential statistics that allow us to establish this type of validity, right? So we're talking really here about how does our type 1 and type 2 errors look, right? How do we have false positive? Do we have false negative? What's going on here? And small sample size is a big threat to statistical conclusion validity, because if you may remember, small sample size means small power, low power, right? So, and if you have low power, that means that you are less likely to be able to reject the null, even if you should. You're less likely to be able to find an effect. Okay, even if one is there. Less likely to be able to find an effect, even if one is there. So we want to make sure we have strong statistical conclusion validity by making sure our sample size is large enough for the study. Okay, and we'll come back around to what is large enough a little bit later. The next kind I want to talk to you about is construct validity. Does the operational definition of a variable actually reflect the true theoretical meaning of a variable? So we talked about operational definitions, right? We talked about breaking something down into its component parts that we can actually measure. And now we have to ask ourselves the question, well, did we do that right? Did we do a good job with that? So when you think about the following constructs, depression, obsessive compulsive disorder, intelligence, love, when you think about measures to actually assess these constructs, are they getting it right? Are they reflecting the true theoretical meaning of these constructs? Okay. What are some threats to construct validity? Well, a couple of big ones are participant reactivity to the experimental situation. Okay, so if a participant wants to perform in a socially desirable way, which most participants do, they want to give the experimenter kind of what they want, and so they might try to intuit that and have a reaction as you know, as a result of that. So that can be definitely a problem. The other problem that can come up is experimenter effect. And these are actions and characteristics of researchers that influence the responses of participants. And it can be intentional or unintentional. So let me give you an example of this. Let's say, for example, that you are in an experiment as a participant and you are going to be given a 200-question survey to fill out. And so one experimenter comes in, and in this scenario, they tell you, oh, thank you so much for coming, and we really appreciate it, and your truthfulness and honesty is so appreciated for this study. And I know it's a little long, but if you can please complete this, we just so much appreciate you and appreciate your doing this. And is really, in addition to saying those nice words, comes across as very friendly, very likable, those sort of things. Versus, let's suppose, instead, an experimenter comes in and says, here you go, fill it out. You might get a different result, right? You might not get as truthful or honest results. People might rush through it. People might not be, there could be an effect there. So the experimenter can have an effect just like the participant can have an effect. Okay. Now, let's turn our attention to internal validity. That's the third, and we'll spend a bit more time on this one. This is the degree to which one can correctly conclude that the relationship between the IV, the independent variable, and the DV, the dependent variable, are causal. So let's talk about the criteria for identifying a causal relationship. First of all, we talked about that you have to manipulate the IV. You have to be able to manipulate the IV. So in other words, let's say it's something like a new intervention to improve mathematical ability. Okay, that's something I can manipulate. I can give some people the new intervention, some people the old intervention. I can control who gets which. I can randomly assign that. Now let's say I want to see if older versus younger people are more adept at solving mathematical algebraic equations quickly. Well, I can't control who's older and younger. I can't say to one person, you please be an old participant, and to another person, you please be a young participant. I can't turn a 60-year-old into a 25-year-old. I mean, if I could, I'd be extremely wealthy. But I can't do that, right? And similarly, I can't turn an 18-year-old into a 55-year-old, right? So because I can't do that, because I can't manipulate the IV, that would mean I could not establish a causal relationship in that situation. Okay, so first you have to be able to manipulate the IV. Next, the cause must be related to the effect. It must have a relationship. We must show, and usually we show this statistically, that there is a relationship between cause and effect. Next, the changes in the independent variable must come before the changes in the dependent variable. And this is called the temporal order condition. Okay, so we got to make sure that if we are doing our study about mathematical ability based on this intervention, we have to make sure that the intervention is happening before any changes in the mathematical ability happens. Okay, and lastly, the toughest one, no other plausible explanation must exist for the effect. No other plausible explanation must exist for the effect. Okay. That's tough. That's tough to eliminate any other possible thing that could be going on there. Okay. All right. So we've got manipulation of the IV. The cause must be related to the effect, relationship condition. And that's often shown with statistics, but you can think about it. Another way you can think about it, that when the cause happens, the effect happens. And when the cause doesn't happen, the effect doesn't happen. Okay. We talked about temporal order, right? That the independent variable has to come before the dependent variable change. And then finally, no other alternative explanation. Okay, so that's a big part of internal validity. So what is a threat to internal validity? Well, the primary threat are confounding extraneous variables. Now, an extraneous variable is a variable that competes with the IV in explaining the DV. It's not wonderful, but it's not horrible. A confounding extraneous variable is an extraneous variable that co-occurs with the IV and affects the DV. Now, that's really a bummer. And let me give you an example. Let's say our independent variable is tutoring, and our dependent variable is grades. Okay, so we want to see if tutoring impacts grades or is associated with grades, and hopefully if it causes grades to change. So let's say we don't use random assignment, but we use 2 intact classrooms to serve as the experimental and control groups. And then we find out that the experimental group who receives extra tutoring shows significant improvement in grades. Sounds good. Except now we find out that the class serving as my experimental group is an honors class. This is a confounding extraneous variable. This is a confounding extraneous variable because I can't separate the experimental group from being an honors. They're one and the same. They're wrapped up in each other. Okay. So things you can do that really help. First of all, the biggest one is random assignment. You can try holding the influence constant, right? We could have done something and try hold the influence constant, but really random assignment's the best way to help with that. So just think about random assignment as your main way to get around this sort of thing. Had I instead assigned students randomly to the tutoring and non-tutoring groups, I probably would have gotten a fair amount of people who were in honors in each group, right? It probably would have split out evenly, close to it. If I really wanted to, that's what I'm talking about when I say hold the influence constant. I could have done like a stratified approach to my random assignment where I made sure that half of the honor students wound up in each group. Okay. All right. Now let's talk about some other threats to internal validity. Now that we've talked about the biggest one, let's talk about some other ones. And these are important too, but they're just not as huge as the first one we talked about. Okay, so the first one here I want to talk about is history. Any event that can produce the outcome other than the treatment condition that occurs during the study before post-test measurement. Now, this typically can be controlled for with a comparison control group, so that's good news. Okay. And differential history is in a multi-group design, right? When you have more than one group, and the event has a differential impact on groups. So let's take a couple of examples to talk about history and differential history, because that's really the best way to understand this. Okay. History. A researcher wants to test a new treatment for bipolar disorder on a group of patients. All patients seem to be showing improvement after 4 weeks. History threat. At week 2 of treatment, Catherine Zeta-Jones announces that she has bipolar disorder and wants everyone who is also suffering with it to know that treatment is key. Can the researcher conclude that the new treatment is responsible for the improvement in the patients? No, because there's that history threat. It could be that they felt influenced by what happened, by this famous person who said treatment is key. Okay, that's what we mean by history. Differential history. Let's say we want to do an evaluation of the efficacy of the WIC program. Okay, and that's women, infants, and children, food and nutrition. Okay, so let's say we want to look at the impact of the WIC program on pregnancy outcomes. Okay. So the experimental group received WIC assistance and the control group did not receive WIC assistance. Now here's the differential history threat. The women who received WIC assistance typically also receive food stamps. So can we conclude that the WIC assistance led to improved pregnancy outcomes in the experimental group? No. It might have been the WIC, it might have been the food stamps, it might have been some crazy interaction between the two. We just don't know. Okay. Maturation. Any physical or mental change that occurs with the passage of time and affects dependent variable scores. Okay. So any physical or mental change that occurs with the passage of time and affects dependent variable scores. So for example, age, learning, fatigue, boredom, hunger, any of those things, anything that happens over time and can affect our scores is really a maturation effect. So you have someone who's taking a relatively long battery of tests. What's going to happen? They're probably going to get tired out. They might get bored. They might get hungry. Now you can typically control this with a comparison group. You typically control this with a comparison group. So if you are, again, this is a threat to internal validity. So we're typically comparing two groups to see if there is a causal relation between our intervention and the outcome. So if one group's going to get really bored, who gets the experimental, hopefully the other group who also is getting this long battery of tests after not getting the intervention will also get bored. So we can take that into account. Okay. All right. Instrumentation. Changes from pre-test to post-test in the assessment or measurement of the dependent variable. Now, in this case, it could be that human observers change their approach to the ratings because they become bored or fatigued. How do we deal with this sort of thing? Well, using multiple observers can help. And training observers on observation techniques can also help. But any change in the measurement of the dependent variable is a bad idea between pre-test and post-test. So we can control some of that. We cannot change our measures, right? Even if we think it's a good idea, don't do it. But some of it, when it comes to human observation, is a little bit harder to control, but there are a couple of key tips here that you can use. All right. Testing. Changes in a person's score on the second administration of a test resulting from previously taking the test, right? Seeing a test more than once influences answers. And also, depending on what kind of test or instrument we're talking about, practice effects, right? If this is a cognitive test and it has similar items or even a similar approach, we learn. We learn from that and we get practice, and therefore the second time we're going to have that effect. This is another one we can typically control for with a comparison group. Now the next one is kind of funny. It's called regression to the mean. And it sounds kind of like magic, but it tends to be true. It's a statistical phenomenon. It's the tendency for extreme scores to be closer to average at post-test. Tendency for extreme scores to be closer to average at post-test. And a regression artifact is an effect that seems to be due to treatment, but it's actually due to regression of the mean. Now, this is a potential problem if you have participants with extreme scores at the pre-test who are selected for study. Because what's going to happen? If they're extremely high, odds are they're going to come down no matter what at post-test. And if you're looking for a decrease, we don't know if that decrease is due to the effect that we're studying or if it's due to regression to the mean. Also, a comparison control group helps here. Okay. Attrition and differential attrition. Attrition is simply dropout, loss of participants because they don't show up or they drop out of the research study. Now, this is only problematic when participants are tested multiple times, right? So imagine a longitudinal study where you're trying to capture students over time and how motivated they are in school. So you want to capture 5th graders, 7th graders, 9th graders, and 11th graders in this longitudinal study where you want to study them over time, right? What's going to happen? You're going to lose. You're going to lose some of your students over time. It's just the way it goes. And that is attrition. That's a problem because we don't know if we're losing maybe the less motivated students, right? That could be. Okay. So differential attrition is in a multi-group design, and the groups become different on an extraneous variable because of differences in the loss of participation across groups. Let me give you an example of this. Okay. Let's say the IV, the independent variable, is a new exercise program, and the DV is we're going to look at weight loss as the outcome. Now, differential attrition is the idea that more participants are likely to drop out of the experimental group than the control group because they're unmotivated to exercise, right? Let's say the control group is something a lot easier, like taking a placebo pill, taking a sugar pill, or what have you, right? Well, or doing nothing. Well, that's a lot easier than actually starting a new exercise program. So you're more likely to get dropped out in those people who are in your exercise group. Okay. Selection. Different selection procedures for different groups. Okay, so this is a production of non-equivalent groups because a different selection procedure operates across the groups. This can be a threat when no random assignment is used in a multi-group design. So for example, let's consider that we're studying energy. Well, we know that morning energy and evening energy might be different. So if we're studying energy in 2 groups, and we have a different selection procedure that operates across the groups, we choose one group who's available in the morning and one group who's available in the evening, and we're measuring energy levels, we might have a problem because of the way we selected groups. Okay. Especially if we put one group, our morning group, in our experimental group, and the other group, our evening group, in our control group, right? It might be the time of day that's actually impacting things. Okay. And then our last set of threats to internal validity are additive and interactive effects. This is produced by the combined effect of 2 or more threats. And in particular, the threat, the interaction between selection and other threats tends to come up more and tends to be an important one. So be on the lookout for selection plus history, selection plus maturation, selection plus instrumentation, selection plus testing, or selection plus a regression artifact or regression to the mean. Okay. All right, so that's internal validity. Let's now turn our attention to external validity. This is the 4th and final type of research validity we're going to talk about. External validity has to do to the degree to which study results can be generalized to and across other people, settings, treatments, outcomes, and times. Okay. So internal validity was all about, that's why it's called internal, within the experiment itself, within the study itself. can we show that the IV causes the DV? And random assignment can help that. External validity, on the other hand, has to do with generalizing outside to other settings, people, populations, treatments, etc. Random selection can help here. Notice the difference, right? Internal, within the experiment, causation. External, outside, trying to go outside, trying to generalize, and random selection can help. So random assignment for internal, random selection for external. Okay, so let's talk about some types of external validity. First type has to do with population validity. Can we generalize across the population? Okay, we generalize across multiple populations. Let's say we show that aspirin is a wonderful preventative for heart attacks. And we show this to be true in the male population. Can we naturally assume that this will generalize to other genders? No, not necessarily. We don't know, right? So we have to work and now test and see if it works with other populations too. So a very strong study might be able to generalize, another one, maybe it doesn't work out. Ecological validity. Can we generalize across settings, across environments? And I'll tell you that laboratory studies really struggle with ecological validity because they're stuck in their little lab. And as soon as you go outside that lab, things might not work out the same. Temporal validity. Can we generalize across times? In other words, think about cultural change. Think about seasonal change, cyclical change. Let's say that you are doing a study about mood in the morning versus mood in the evening. Well, let's think about that across seasons, right? People's moods in the morning and evening might be different in summer versus winter. Also with cultural change, as we know, attitudes certainly change over time. So our study might not have the same effect. Our feelings about online education might really not have generalized very well from before COVID to post-COVID. We'll see. I don't know. But that may not work out because of this big cultural shift. Treatment variation validity, variations across treatment. So with this one, let's think about cognitive behavioral therapy as a treatment for people who express depressive symptoms. It's a very well-known type of therapy. But does it work the same with different therapists? Might there be a threat to treatment variation validity due to different therapists? Now, how do we fix that? Maybe we manualize the therapy a little bit. And some types of therapies have been manualized to try and help that. But then you might come back and say, but still a therapist to therapist, there might be differences there. So that's something you want to consider. And then finally, outcome validity. Now we're talking about generalizing across similar outcomes. So let's say you're looking at a job training intervention aimed at helping people get a job. So does getting a job also mean keeping a job? Similar outcomes, but yeah, you see that maybe you have one without the other. And you really ideally probably want both if you're working at a job training program, right? If that's your intervention. Okay. So these are all types of external validity. So again, we started talking about 4 types of validity: our statistical conclusion validity, our construct validity, our internal validity, and our external validity. Okay. Now, I just want to again emphasize, even though I already did before a little bit, notice the relationship between internal and external validity, that they're often inverse. Typically, as one goes up, the other tends to go down a little bit, because the more natural that you make a study and the more that you get that external validity due to random selection, sometimes you're sacrificing some of the tight controls that you need for internal validity. And think about the laboratory versus the field experiment. It's sort of a similar thing, that sometimes the benefits of one are the disadvantages of another one. So I'm not saying you can't have both, but there's often, many times at least, an inverse relationship between the two. So it's something to think about, which one you really want to emphasize. You're really emphasizing the causal and doing your random assignment to make sure that's working, or you're really going to emphasize that external validity and really emphasize the random selection and maybe getting things in a more natural state, that so that you can generalize across these different settings, populations, etc. Okay, so something to think about. Okay, that's all I have for you today. Take care and stay well, and I will talk to you next time.